All right. Good afternoon. So how are things on the first day of the conference so far? Good? All right. So my name is Sam. I've been in the Active Directory team for closing in on 14 years, I think. So I joined in '98, and I was fresh out of college, and I joined the Active Directory team working on core replication. As part of Active Directory domain controllers for Windows 2000 was the first time we released Active Directory. So I've been around the identity space. It's always been a lot of fun and challenging in different types. Right now, I'm a lead program manager, mainly owning all of Active Directory Federation service, as well as a bunch of core components in Active Directory that was responsible. I think some of you might have already heard of dynamic access control in Windows Server 2012. So those are some of the things that I worked on. Today, I also see a lot of faces from an earlier lunch session today as well. And some of the content today is going to be a little bit of a repeat from the lunch session, but we'll be expanding on that and talking about in more detailed form in this session. So what is this talk about today? So mainly, we're going to focus a little bit about why are we really thinking about Active Directory? Hey, it's just a domain controller running on a virtual environment. We already do that today. What's different about it? You know, are we going to be talking about every set application that can be virtualized? Yes and no in this perspective. It is just like running a virtual DC, but there are some special considerations. So we're going to focus on that during this session in terms of what you need to consider as part of your design as you consider hosting domain controllers or hosting applications on Windows Azure virtual machines. So for some of the areas, we're going to really think. We're going to talk a little about some of the drivers and the scenarios associated with thinking about Active Directory in the context of Windows Azure virtual machines. There are two portions out there when you really consider. One is about thinking about Active Directory is not much without an application that it serves for. So, for example, in our world, we call Windows Client an application because, in a sense, Windows Client is tightly integrated with Active Directory to provide login support. Similarly, you have numerous workloads that depend and are tightly integrated with Active Directory. So you can think about Windows Azure virtual machines and Active Directory in the context of an application that you might want to move up into Azure, or you might be thinking about it specifically as the domain controllers themselves. So let's have a show of hands around this. So, right? How many people are thinking about, from the perspective of this session, of hosting SharePoint in Windows Azure virtual machines? Okay? We have a small. How about SQL Server? Okay, some more. How about just thinking about domain controllers being hosted as like a separate data center for geo-distribution? Wow, okay, quite a few more. How many are thinking more about it from the perspective of using this as your backup or secondary data center for you to do failover? Okay, cool. So it seems like we've had more people really thinking about it and saying, hey, how can I host these domain controllers that kind of drive either a better geo story for me, or thinking about it from the perspective of branch office, for example, or thinking about it purely as a disaster recovery kind of a solution because I have that level of connectivity up. The machines are going to be fairly reliable as provided with the SLA provided by Microsoft and driving that. So we'll talk about that in a bit. How many of you thinking about it from the perspective of Federation service? Okay. All right. We did not focus this session a lot on Federation service, but if we do have time, I'll probably chat about that a little bit as well. All right. We talked a little bit about, you know, from the questions that I just posed, we have a sense for what are the kind of drivers in terms of getting Active Directories connected to Windows Azure virtual machines, either from the perspective of providing domain controller support for authentication and authorization for Active Directory-enabled apps, or for being able to kind of use as a secondary data center for Active Directory domain controllers themselves. Now, one of the things is that, like initially, when I kind of started working on this a little bit, my first reaction was, hey, it shouldn't be no different than running on a virtual DC. How many of you have virtualized DCs? All right, wow. This number seems to be growing every year that I've asked this question. So it shouldn't be that different was my initial take on it. But as we worked with the Azure team and kind of ran testing on this, there were a few details in terms of how to think about it that we wanted to make sure that people who are considering this take into account. Because there's an aspect about thinking about traffic optimization. There's an aspect of thinking about the gateway. There's an aspect of thinking about how you manage your replication itself. If you're using replicas across in your organization's network environment as well as in the Azure's network. So these are factors that you need to consider as you think about deploying Active Directory domain controllers in Azure. Okay, before we get started, there's a few things that is good for us to level set in terms of some of the core concepts and terminology that we use when considering Windows Azure virtual machines. Now, how many of you attended Mark's session at about 11:30? Was it? Yeah. All right. So Mark did cover a series of core concepts around Azure virtual networks and Azure virtual machines, from which we build on. But I wanted to kind of go through a few of some of the terms. Now, before we start, how many of you have heard of the term Windows Azure Active Directory? Okay, that's not what we're talking about here. All right, Windows Azure Active Directory, think of that as more of our platform as a service capabilities that we provide to applications that are hosted in Azure or these are cloud services. And one example of that is Office 365 as well. So that's not something that we're going to focus on today. But when I've had quite a few people get confused with the notion of, is this the same as Windows Azure Active Directory? This is Active Directory domain controllers running on Windows Azure virtual machines. So think of it as IaaS and infrastructure as a service versus platform as a service. OK, a few of the terms here. The first is Windows Azure Virtual Machine. This is the pure notion of a virtual machine running on top of the Azure Virtual Machines fabric. This is nothing more than thinking about what it is to get compute power, where you have other organizations like Rackspace, Amazon provide some notion of this as well already. So this is an equivalent of that based on the overall Azure infrastructure and its set of capabilities, which also tightly integrates with our platform set of capabilities as well. Windows Azure Virtual Network is the concept of building your own sets of virtual networks in Azure such that you can think about how you drive isolation schemes for example, you might say a virtual network has access to the extranet, but one of your virtual networks does not have access to the extranet and only has corp connectivity or your site through your site-to-site on-premises connectivity. It also, as I just did say, it also includes the component of being able to connect the network from your on-premises network over to the cloud network. So, for example, if you had a replica DC that was hosted in Azure, you need some way to be able to replicate that information across. And that's called the cross-premises site connectivity, I think, is the term that we landed on. And it also contains that portion when you think about Windows Azure Virtual Network. This is very integral as part of thinking about hybrid environments where you kind of have domain controllers that live in the cloud as well as on-premise. Okay? That portion is, the way to think about it is I'm just extending my inside network up to a portion in the cloud. And some of you might have already done something similar with respect to having secondary data centers and how you manage the networking as part of your secondary data centers. Okay? Now, we're moving on to two more concepts out here. One is a virtual IP address and a VIP, as well as a dynamic IP address. A VIP is pretty much what you normally know of, where it is a single network endpoint from which you might have ability to kind of fan out to multiple applications or multiple servers. All right? This is very important from applications like web servers, which typically tend to have a farming concept as well. So you provided one endpoint, and the load balancing takes care of the rest. Now, the next one is something called dynamic IP address. This is a little different. Now, typically, when you think about dynamic IP, or when I thought about dynamic IP, I thought, hey, it's nothing much more than me getting a dynamic IP from a DHCP address. When the lease expires, I get a new IP address, and that's fine. All right? But Azure's networking environment has something unique. It is the fact that while it might expire, the lease expires, you are guaranteed to get the same IP address back. The underlying Azure's infrastructure as a service fabric provides that level of guarantee. So why is this important? It is important from the perspective of domain controllers because, in general, a recommendation is to provide static IP addresses for domain controllers, right? So whereas static addresses don't necessarily, static addresses from the guest machine or the virtual machine don't necessarily work in the same way in the Azure fabric. So for domain controllers, if you want that notion of it being static, you need to ensure that it has a dynamic IP address. We'll cover about it a little later as well. Okay, just for fun out there. But one of the core value propositions of infrastructure as a service is the fact that you do not have to really think about managing the hardware, whether it is your memory, your network, your card, your disk, and that's all provided as a benefit for you as part of the service in Azure. And it handles everything. But what does that truly mean? It means that the Azure fabric has to handle these types of events, because these types of events happen. That's just the law of physics out here. All right? You are going to have a bad network card. You are going to have a drive that gets corrupt. All right? You are going to have memory that gets corrupt on the host. Azure provides the ability for it to manage that in a seamless fashion such that you do not have the view of saying, you still get the same reliability of service. Mark was talking about the notion of thinking about single instance roles versus multi-instance roles, and how do you think about affinity groups and availability sets, and how Azure separates those instances such that when it is transparent to the user, because underlying there might be a VM that moved from one host to another or got recreated, but that's all totally transparent. It's totally oblivious to either you as the end user or the admin, because that happens under the covers, and you don't have to worry about. And that's one of the core value propositions of Azure. So there is some aspects of service healing. Now, within service healing, what are the key things that happens as in when a service healing event happens? From Azure's perspective, on a virtual machine, the MAC address is likely to change. Similarly, the processor or the CPU ID is likely to change. However, as I mentioned about dynamic IP addresses, that will stay the same, and that is guaranteed by Azure. So if you had assigned a certain IP address to that virtual machine through excuse me, through it being a dynamic IP, then that is essentially going to continue to work. And similarly, we'll talk about it, the notion of why this happens as well. None of the writes that happens to the directory is going to get lost through that service healing event. We'll talk about it in detail a little more. Okay? So bottom line is that when there is service healing that might occur, all right, you have to always think that it will occur at some point in time, the virtual machine is still guaranteed to kind of work seamlessly and work well across these service healing events. And the Fabric provides you the right level of being able to direct traffic appropriately to the various machines in the various availability sets to ensure that you have a continued access to these services. All right, so let's talk a little about considerations for cloud deployment. Yes?
In the multi-domain scenario, what would happen to the RIP pool?
We'll talk about that a little bit in a context of thinking about USNs. All right. All right. So before we start thinking about some of the detailed choices that you have to make, I'm going to kind of break it up into how I think about it as the types of deployments that exist. It's pretty simple. One is the notion of it being a cloud-only deployment. So imagine a scenario where you probably already have a DMZ environment where you've got a set of applications that might live in the DMZ, and you also have an Active Directory associated with the DMZ because you might be using it either for managing the machines themselves because it gives you the ability to control group policy in a common way. You might be using it for those reasons. Or you might be using it to host a whole bunch of extranet users. All right? Because we see that pretty common where you have applications that need users from outside. Organizations tend to isolate those environments from the corporate directory, host that in a Active Directory forest that is in your DMZ environment, and it may or may not have a one-way trust to your Active Directory inside your environment. We've seen it go both ways. So that environment is very akin to thinking about a cloud-only deployment. A very good example is you might have a extranet-facing SharePoint site, all right? And you might just say that, hey, I don't need to manage these machines anymore. I can just host it up in the cloud and have the Microsoft Azure service take care of managing the servers, but I still have the SharePoint site up. And you might, in that SharePoint site, be using Active Directory accounts in your extranet forest to log in. That whole environment can be moved over to Azure, and it can support the ability of it continuing to be the seamless access story for your end users for extranet connectivity. So think about your cloud deployment. That becomes a pure isolated deployment where there's no connection to an Active Directory environment inside your network. How many of you have such an environment already in your DMZ? Okay, I see a few hands. The next way to think about, next scenario for you to be thinking about is what we call a hybrid deployment. In this view, hybrid means that there is some sort of connection between your corporate directory and this cloud network that you might have. And that connection may have different characteristics. One is the connection might be to support domain join clients, so or domain join servers, because your apps run them. Or the connection might be purely to do DNS resolution, all right? Because your DNS, think of it as an extension of the internal network in some ways. Your DNS is still located on-premise or somewhere else, and you still need to be able to bridge from the cloud to corp at that point in time. Or it could be just replication traffic because you have everything located out there in the cloud, and the only thing that's passing between for you is that replication traffic when changes do occur. So when changes are authored in corporate side, it can flow into the, let's say, provisioning of users, for example. All right, it can still happen inside your network, and that can flow seamlessly into the cloud, and you've got all of that access on the cloud side. Or you might make changes in the cloud, which I think will be less prevalent, and that can flow back inside as well. So at a very high level, those are the two ways you think about your Active Directory deployments for Windows Azure virtual machines. So let's kind of have a few diagrams to at least kind of hone in the point here. So as you can see in this diagram, it's a specific cloud-only environment where you have an domain controller up in the cloud. Think of it as a brand new forest with one domain. and you have the client, which is the app server that is domain joined to that cloud deployment. So now you have the full capabilities just like you might have internally for that deployment, where you can take one of your on-premises applications that had which was Active Directory enabled, and you can make that work seamlessly up in the cloud as well. Okay, and this, while we fundamentally, this wave that we have in Windows Azure focuses primarily, we've kind of focused on our high target applications as part of that, which we looked at it from the perspective of SQL, SharePoint, and Active Directory. These are the three things that we took the first step in terms of doing this and making sure that these work seamlessly across. But that doesn't mean that any of your other Active Directory enabled applications, either that maybe even use LDAP bind as well as LDAP lookups into your directory, can work in that same environment. So, but this is SharePoint Exchange, and its relationship to Active Directory was the key things that we focused on in this first wave. The next deployment is, hey, thinking about it being much more of, excuse me, the applications living, on the right side you can see the applications living in the cloud network, right? So we threw in some IIS servers, we threw, with SharePoint on it perhaps, and we've got SQL in there. But the key, and there's a key component called the gateway. And the gateway, Mark kind of went over this very quickly, but the gateway is the key component there that can provide you VPN connectivity back to your corp network, all right? So that's something in which you set up a virtual network, you can bind it to a gateway, and then you can generate a script to be able to onboard that gateway endpoint onto a VPN device of your choice. And I think Mark showed a Cisco where he set it up with a Cisco VPN device. So it could be any VPN device that lives in your on-premises network that you can bind the gateway to so that you get the cross-premises site connectivity enabled. Now, excuse me. So the one thing that you notice out here is that there are no domain controllers out here. All right? This is possible for you to do. All right? And what is it like when you don't have domain controllers? What does it mean? Every time that one of those machines goes up and down, the traffic to authenticate goes all the way through that the tunnel to connect to your on-premise domain controllers and then authenticate. Right? There's one of the things that for you to consider is that while ingress traffic from the corp network to the cloud network is free, the egress traffic that flows from, which is initiated and flows from the cloud network to the corp network, has a charge associated with that. So when you take that into consideration, there are a few things in the lunch session. I think a few people, you should consider what that egress traffic means for your deployment, for you to kind of make the right choices. But in this type of a deployment, you're more likely to see an authentication and DNS query move across that link. And whether that incurs a large cost or not is based on the deployment of your app and your app patterns. So that's something that we strongly encourage you folks to kind of look at and see what makes sense to you. Now, the next deployment is very simple. What we did is that we talked about this DNS traffic and we talked about that authentication traffic. Now, all we had to do is to put a set, a domain controller, a set of domain controllers that reflect your environment, your Active Directory for us, to be able to be co-located on the cloud virtual network. What does it give you? This gives you the full capability that there are few advantages in doing this. A is that I just talked about egress traffic. So there's very little traffic between the cloud network and the on-premises network, and it is limited only to replication traffic that flows through. All right? So that's something that you have out there. Secondly, one of the key things that it gives you is that you have a fully capable, fully resilient environment in the cloud. What it means is that let's say that your SharePoint service was still being exposed to the extranet. All right, you can still have the view of the cloud network, the virtual network, still have the perspective of an extranet and an intranet, so that your domain controllers are not accessible directly from the extranet. Still, you have a full networked resilient solution. So in the event of any form of a site, the connection between the corp network and the virtual network goes down. Excuse me. Corp network goes down, or if one of your own data centers goes down, the application still is accessible from outside the network, which is your predominant use perhaps in that case, and it can still continue to authenticate in a fully resilient fashion. So that's a key advantage in actually doing this, because it gives you a full isolated environment that still works well with your organization's environment. But if in event of any connectivity issues, you still have a lot of the isolated environment gives you protection and gives you a better sense of availability. Any questions so far? Yes. Everyone understands everything? It's simple, right? Okay. All right. No, actually, it is simple, because for the most part, it looks just like a virtualized DC. But hey, a few things here and there, think about it. And that's one of the things that we want to kind of make sure we got it out. By the way, we will be releasing a white paper pretty soon that goes in-depth detail about the scenarios with walkthroughs on how to set it up end-to-end across the board, how to think about your Active Directory environment and some of the safeguards. We will produce this in much more detail. I've captured some of the issues or design choices that you'll have to make, but that's something that we'll provide as a white paper with step-by-step instructions pretty soon. Okay, so now we kind of get into a little more of the details out here. So what are the specific points to kind of consider? Starting all the way from, hey, can I virtualize a DC? And it looks like here people think that everyone, it's okay to virtualize DC. But there's a few things to watch out for. So let's make sure that we provide the necessary guidance in terms of doing this as safely as possible. And ranging all the way to really thinking about, hey, does an RODC make sense or not here? That seems to be perfect for my environment, because I can think of modeling this just as a branch office. And that's exactly what RODCs were meant to do, so that they can be run in a secure environment. So is it really secure? Is it not secure? We'll have a few points about that. Similarly, and also thinking about your IP address resolution and naming as well. So let's start with, is it safe to virtualize a DC? About 2 years ago, when we did Windows 8 planning, we spent, at least from the Active Directory team, we actually spent a lot of time reviewing support data from customers on what some of the key challenges and problems were. And we actually spent quite a few hours working with our support teams to bucketize the key areas. And some of our investments were all based on how do we reduce our support costs. One of the areas in terms of support cost is people actually having a non-convergent directory because of certain actions that they performed on domain controllers running on a virtualized platform. Okay? Why does this happen? Active Directory is pretty much a distributed database. We have multi-master rights, right, across a whole bunch of nodes. And somehow we run some magic to essentially make sure that they all converge in them. We have special code, especially relating to security principles, when we create, so that when merge conflicts happen, certain things occur. Now, how is that algorithm based? Fundamentally, it is based a little bit on a vector clock algorithm. So if there are certain things that go wrong with that vector clock, the directory does not know how to converge. Right? This was not very prevalent in pre-virtualization days. But with virtualization, it was easy to actually get into a state where you do get to that divergent state where domain controllers across two nodes may never converge on the same data. All right? How many of you have heard the term USN bubbles? All right? Has anyone ever faced an issue with USN bubbles? All right. Good, because it takes hours and weeks to essentially get past that, where in some cases you're doing a full forest recovery. All right? So what does that really mean? All right? The virtualization platform gives you the capability to roll back in time. And it does so in a manner that the directory infrastructure has no knowledge of it. So we do not know, for example, in the AD side, when whatever code is in the AD side, does not know that an administrator or IPv admin, essentially by mistake, all right, just said, hey, restore to a previous snapshot. Okay, because they thought, hey, that's kind of cool, you know. There was someone said something about it, so I just made a, you know, let me just roll back in time, and everything is good. Right? This doesn't work because Active Directory does not know how to deal with that. We do not know. We already have mechanisms in which we can resurrect ourselves from an older copy of the data. So by virtue of us changing the invocation ID and replication, our replication algorithms understand how to deal with that and reset replication in certain paths so that we can converge on the data consistently. But when hypervisor platform rolls that back in time, we do not know what to do with it. And we'll think that, OK, everything looks good, time is current now, and we'll continue to accept updates. And this is a place where we create the USN bubble. So let's talk about what this looks like. Okay? So let's assume you've got DC1. Okay? The USN is an acronym for update sequence number. So let's think of it as a number where every change has a certain, atomically increasing number, right? So that's at a level 100. And there's a certain ID for every domain controller, and that's at 8. Now, this domain controller also deals with creation of security principles. So it has a RID pool associated with that so that it can provide a unique SID, which is one of the reasons why we have that RID pool and a RID FISMO, standard Active Directory stuff. So let's assume that has the RID pool of 500 to 1,000. Now let's assume in time T2, we just added 100 users. Okay? So what does that mean is that your USN just bumped up to 200, and your RID pool, available RID pool, is now from 600 to 1,000. Okay? And this just got replicated over to DC2, where DC2 now received updates from all the way from 100 to 200. So think of these as new users. Now let's assume that we roll back to T1. Now that state of that is now USN 100. And the RID pool is now still back to 500 to 8,000. So when a new user gets created, it thinks it's got 500 to 1,000 and will assign the appropriate SIDs based on that logic. Okay? 150 more users get created. And now you can see what happens is that the RID between the first 100 users out there, you have a reuse of the RID pool that shouldn't have been reused. So what it implies is that you're likely to get into places where you're getting conflicting SIDs, so which essentially will probably, once they do replicate, you're going to get into a problem where, both will be disabled at the end of it. There's some safeguards in place, but that's still a problem for your environment because suddenly your users won't be able to log it. Now, but the worst problem is that from 100 to 200, right, the changes that were previously made have been totally lost in the environment to DC1 because it will never get back those changes. Now, if it had a different ID, the algorithms essentially can handle that, but it does not. So what essentially it results is that you've only got changes greater than 200, and you've lost all changes between DC2 does not know about changes from 100 to 200 in the newer case, and DC1 will never ever know about the the older changes that happened between the time the snapshot was taken and when it was restored. So this is what we call a USN bubble, where our data has diverged. And the system fundamentally has no way to handle that. Now, we've made an improvement in Windows Server 2012. It's called something called VM Generation ID. I do have a session in much more in depth of how that works, essentially. That will help improve this area so that there is a better knowledge between the hypervisor platform and Active Directory. And we're also working with other hypervisor vendors as well on this. So that's one aspect of it. Yes?
Question, if the physical role for Ritmaster would be on DC2,
Yes, because what happens is that periodically a domain controller asks for the RID FISMO owner for a pool of RIDs. It still has that pool of RIDs, which it doesn't invalidate when you do the snapshot restore. Because otherwise, for every request, you're still kind of going back to the RID FISMO to do that. OK. So this is something. Now, why did I bring this up here? Because underlying on Windows Azure virtual machines, you still have a hypervisor. All right. While the Azure Virtual Machines fabric does not necessarily let you easily snapshot and restore in the way that you could do on this, there are still certain characteristics that result in this potential condition. All right? We've seen support cases where people thought they could copy a DIT, like, for example, copy the VHT over, where one of their VHTs got corrupt, and they had taken an exported VHT, and they just copied it to the virtual machine and restarted that. This is no different than being, what I just mentioned, where the rug is just pulled underneath us, where we don't know what's going on in that case. All right? So do not use copy to restore back to a previous state. So that's the bottom line for this story. OK? And of course, all right, simple things. You can't sysprep DCs. So that's not something that we offer. But in Windows Server 8, or Windows Server 2012, I keep calling that Windows Server 8 because we keep referring that internally that way, we also have, as part of doing this feature, we also did this notion of being able to clone a DC where, because we are the domain controller, we control the security account infrastructure, we can take the whole OS for a ride. It's not very easy to do that on other types of workloads, but that's something that we can do. So that's something that we do support in Windows Server 2012. So as I mentioned, the feature that we did in Windows Server 2012 is not currently available in the hypervisor platform that runs on Azure Fabric. This will come over eventually at some point in time, but for now it's not available. So this is where we really have to be careful in terms of doing this. Now, another aspect of this is that in the event, like as we worked through these details, in the event that you still created a new virtual machine and attached a VHT to it, the VM generation ID will change. We'll talk in more details at the subsequent session on virtualization of DCs. Any questions so far? Are we done on time? OK, good. All right. Now, so this is an important concept as well, okay, for you to consider when you are deploying Active Directory domain controllers on Azure virtual machines. Azure virtual machines have two forms of disks. One is an OS disk, and one is a data disk. The OS disk is something in which it is more optimized for dealing with smaller amounts of data. So what that essentially means is that by default, there's write caching enabled, because that has a lot of performance improvements in terms of having that OS disk there, because you can cache locally before you push into the Azure Blob storage as a persistent VHT. Think of it as persistent VHT. However, with Active Directory domain controllers, like I said, there might be certain things about the local state that needs to be persisted. And by default, for those of you aware, when you set up a domain controller, we essentially disable write caching on your disks. All right? So when you are choosing a data disk, which you should, if you are deploying a domain controller in Windows Azure, you should essentially make sure you keep an OS disk and keep your NTDS DIT file, which contains your directory data and sysvol, on a separate data disk. What the data disk offers is that by default, write caching is disabled. So what it implies is that whenever you make a write, it's flushed straight to your persistent storage. So there's no buffered memory in there. And this way, if there is a service healing event that happens at any point in time, we're assured that we haven't lost any writes from the directory onto the disk storage. So this is why you do that. Similarly, if you were like, you might do that even today, because you might have like even a SCSI emulator mode where you've got forced unit assertions. So that gives you the same capability in which you're always flushing data to the disk at the point in time of writes. So keep this in mind. Gotta make sure that your NTDS DIT sysvol essentially is on a data disk. Any questions? Okay. Now, another key vector for thinking about deploying domain controllers in Azure is about the cost vector. And we bring in the cost vector purely because there is a cost associated. You never had to think about it before, right? You never had to think about cost between two machines in your environment, because you put down that one-time cost in your network, and you got your pipe for free, right? But there is a cost in egress traffic when there's data that is moving from the cloud endpoint into the corp, into a corp endpoint. So you have to kind of consider this, and we have we'll talk about this a little more. Now, to do this, for people who are aware of RODCs, read-only domain controllers, read-only domain controllers were built with the notion of reducing traffic between the read-only domain controller and a fully writable controller that may live in a main site. Our motivation for that was different, and I'll get to that in a bit. But it does seem that RODCs seem a fairly effective way in really for you to kind of think about managing cost if you're running it up in the cloud. Of course, with RODC, you have to think about some of the standard things that you already think about RODC. What are the type of users that authenticate, all right? Like, do you have to, because the first time authentication always traverses through the network, all right? And then the credentials are cached locally. There's key isolation between the domain controllers, the RODC domain controllers, and the network. But it was meant to reduce that traffic as much as possible as part of us thinking about branch office in, when was that? Windows Server 2008, I think. All right. Now, another key aspect is really thinking about both your DC locator, which is where your clients reach DCs, as well as your replication site links themselves that impact how replication topologies are created by what's known as KCC, which is our replication algorithm that spans across multiple nodes, figures out what's the right topology to build based on one site versus another, between DCs within a site. All of those, we've had that infrastructure with continued improvements all the way from Windows 2000. So one of the key things to really think about in this case is that your whole goal is to dissuade any clients not to reach your Azure DCs unless you really think that they need to, all right? And the way you control that is really thinking about your virtual network up as a distinct site, all right? And you can now control the cost of the site link between one of your organization sites in your network and one of your Azure network. So if you push that cost up sufficiently, the algorithm, both from a DC locator as well as the replication algorithm, sorry, the DC locator is slightly different, but from the replication algorithm's perspective, it will avoid creating any topologies where you're preferring your Azure Networks DC. So that's something for you to kind of think about. So for example, if you had a cost of 50 between your own data center in, let's say, the US and a data center in Europe, all right, you would potentially, to dissuade replication from flowing from your data center in the US to your data center in the Europe through the Azure data center, all right? Don't want that. So you have to make sure that you throw in appropriately a high cost on the cycling, which will ensure that the algorithm is doing the right things out there. Now with DC Locator, right, you don't want your internal clients to be hitting that Azure DC at that point in time if you have site-to-site connectivity up. So standard ways, you can reduce your you can reduce the weightage of that site, and your DC Locator algorithm will essentially take care of fundamentally finding your DC. If it couldn't find a DC in your site, in the client site, if it can't find one, it will find one with the least cost, and so hopefully it'll find another one within your own network so that you're avoiding that traffic going up to the cloud, and you're limiting the traffic only between communication that's within the Azure network, for example. Any questions on this? All good? Or is it a little too late in the day? All right. Okay. I'm going to force and make sure that I'm going to have you people ask a few questions very soon. I started talking a little bit about RODC. Okay. So when we started having discussions with the Azure team about what does it mean to deploy domain controllers in Azure, our first notion was, hey, it seems like really thinking about RODC seems to be a really good way to think about it. We've gone back and forth on this. RODC was really meant for dealing with branch offices where you did not have good enough reliability on the hardware infrastructure. And you could kind of be able to isolate that environment in smaller, reduce the notion of traffic, but a lot of it is focused on providing security isolation. Okay? Now, that debate moved. Yes?
Isn't that the first question then? Do you categorize Windows as your data center?
Now, that's great segue, because that's exactly where. Then the debate become, do we think of Azure as being secure, or do we not think about Azure as being not secure, Sorry? How many? Okay. So, all right. How many of you think about an Azure data center, let's take an Azure network, as being secure for your organization? Wow, okay. It's 50-50 or maybe 40-60, all right? That's not bad, all right? Because that's where our debate was. From the perspective of Microsoft, we think about it as secure. So we have a standard process in which how we drive things. There's security clearance to that. There are some other folks out here who have to go through a rigorous, aspect of being able to who gets to access what. There's a series of things as part of doing that. But again, it's going to be your own organization's perception or your customer's perception, whichever role that you are in, all right? And that's where we kind of differ from RODC's perspective. RODC was meant for it to being an insecure. We see it as being secure. But it is up to you to essentially drive the right characteristics within your organization or with your customers based on how they think about it, right? Because one way to think about it is this is just nothing but a isolated extranet kind of access deployment for you as part of doing that. But if you want more forms of thinking about it as being disaster recovery or thinking about it as a failover site for you, then you have to kind of have this, because you are going to host those domain controllers or your token servers in terms of being there. So that's something for you folks to kind of really, consider, whether it is about, because these are your accounts, these are some of the keys to your kingdom, and there are varying considerations for you to kind of think about it, and some of them are not technology in nature. Some of them are very business. Whatever your current set of business policies may not necessarily dictate any of those types of servers actually moving across into servers that is not controlled by you. Now, one example is that, hey, we don't think the government, for example, it has a set, is going to do that. But that's one of the reasons why we have more specific configurations for the governments, for them to have more control into the detailed specifics about the infrastructure management, or some countries won't allow that either. So that's a different scale that we're also approaching as a problem. But as a general purpose service and running domain controllers for customers, there are benefits. there are perceived disadvantages. That's something that, we've just started this out. We're still going to see how customers think about it and get feedback. And there are things that we can do, improve on the technology aspect. We will definitely continue to consider that. Okay? But again, from an RODC perspective, as you can see on the last point, we don't replicate anything outside. It's always from, so the amount of traffic that really goes across that channel is very low. It is based on even your traffic that authenticates out there, where your credentials pass through to the RODC is fairly low in nature. You also have the ability to control your attribute set for RODCs. So if you mark the flags on the attributes, only then, of course, these have to be non-critical attributes in AD. But if you can mark them, you will limit flowing that traffic to those RODCs as well. So you can definitely consider RODCs as being an option for you. If you're on that insecure side of the house, where you're hesitant to deploy a domain control in Windows Azure, you can definitely use RODCs because it was meant for that type of an environment. Okay. Yeah?
Like RDC, does it support Exchange, SharePoint, AD?
I've heard back and forth about Exchange having some issues. But it should all be configurable and can be made to work is what I understand.
So SharePoint and ADFS will work?
Yes, ADFS works fine with RODCs. Because ADFS, the fundamental thing that ADFS does is that it mainly uses an authentication head. The rest is about reads, ultimately. We're not doing writes. Exchange, whereas, requires a whole bunch of writes. SharePoint, less in terms of writes. So, okay, now moving over. GCs, which is global catalogs, are definitely needed in thinking about if you're hosting something up in the cloud. Now, what are the key things that GC kind of does is on a login, you want to get the universal group membership list, which is hosted, which GCs can rationalize because they have a partial copy of every domain within your enterprise. So that's something that you have to consider. If your applications in the cloud need, some form of ACLing based on universal groups, it's a good thing for you to ensure that a global catalog is available up in the cloud. Now, if you're thinking of it being as part of your forest recovery or disaster recovery type of an environment, you definitely want to have a global catalog out there, okay? Because otherwise logins kind of don't process very quickly. That's pretty much of the key things out here. Let's move forward. I think this goes back to a point that we were briefly discussing. It's trust, replicate, or federate, probably is how I would say this. Okay, and I think this is going to be fundamentally based on how every organization thinks about specific parameters that drive a decision in this area. Cost might be one of your biggest factors. Security might be your biggest factor. Data that is stored there might be a biggest factor. And similarly thinking about resiliency and fault tolerance. So I keep reiterating this because in some ways we are learning with you as part of those deployment patterns, and as much feedback that you folks have to provide us will work towards where areas we can improve our technology. We'll continue to work in those areas. Where we can help clarifying for guidance, we'll continue to do that. But at this point in time, I think it is a choice that each one has to make on their own to decide what are the types of topologies that you're going to do and what are the pivots by which you're going to make decisions. And this is why even in our step-by-step guidance, we're going to talk about what are the pivots that you need to think about, but that ultimate decision is yours. Now, the bottom line from on the Microsoft standpoint is that, yes, we will support running Active Directory domain controllers on Windows Azure virtual machines. So if you have a problem and you call support as part of that, we will support that, and that's no different from some of our support statements today. I think an earlier conversation in lunch was, hey, I didn't, or we didn't run domain controllers on virtualized machines because we were told that that's not supported by Microsoft. That's not true. We do support running domain controllers on virtualized hardware, as a virtual machine. And the key thing is that if you do perform a virtual an action provided by a hypervisor platform to restore back in time without the domain controller knowing about it, then it is difficult for us because it becomes a data divergence issue, and you have to, yes, support will say, sure, we'll help you out, but that's going to be a costly endeavor for you as a customer. Now, oops. So, again, this is something that I mentioned earlier, is the notion of a DIP, a dynamic IP, is very different. I call the DIP as a pseudostatic IP because even though it expires and it gets renewed, the fabric ensures that you get the same address back. So essentially, you get a static address. So the way this is kind of interesting because we were thinking about, it's an interesting story as well. We were thinking about, like, how do you automate the deployment, for example, across Windows Azure virtual machines in terms of creating a new VM? Now, the interesting thing is especially around DNS name resolution, right? When we create the virtual machine for the domain controller, we don't know the IP address for the first time. So you don't know what to provide for the rest of your machines until that domain controller comes up and then has an IP address provided, a dynamic IP address provided to it. And that, so for example, if you're hosting DNS, then you need to provide that as an infrastructure for other machines to do resolution on it. Now, one of the challenges was that we can't create it automatically across that, so it has to be a staged event. So our guidance, for example, states that you do a loopback address for the domain controller with DNS, and then once you have the IP address, then you use a primary DNS server as the cloud DC, a secondary DNS server as potentially a different DNS server that might even live on premises, and then have the clients, once you have that information, then you can provide that as information to the whole of the virtual network. So anytime you create a virtual machine in that virtual network, you will be able to inherit those settings around what my DNS server settings to be, so that name resolution works great if you're sysprepping machines and you're bringing everything with domain join, for example. You might be sysprepping machines and then do a domain join experience as well with it, and all of them happen seamlessly for you. Any questions? I'm told that most Indians speak very quickly, so feel free to interrupt me at any point in time. And because I realize that I'm getting through my session a little faster than I anticipated, too. But, hey. We strongly recommend that you do not use Azure DNS. While it works for some scenarios, for more complex scenarios, we recommend that you use ADDNS to essentially do your DNS query, name resolution, and not rely on Azure DNS for any of your machines that's hosted on there. So it kind of becomes pretty much the same paradigms that you're normally used to within your environment, and it doesn't change that much. Yes? So there's again, this is a release preview, still a bunch of stuff working. The challenges on dealing with SRV records, it doesn't support that. It's more of CDEM or A records that it does support, was what I'm told. But I'm also told that they're making changes as well. So at this point in time, our recommendation is use ADDNS or an alternate DNS server of your choice. Okay. I talked about the fact of DNS making sure that you think about loop back addresses, and then getting that first DC before you have to have it operational before you can supply it to the rest of your clients in your network. So that's something that you have to consider. Okay. Now, a lot of you brought this up as being a way in which you think about the scenarios as well. This is about giving you geo reach because, hey, your business is expanding. You have users in different parts of the world that need to connect. You trying to host your own network up in all of these various pieces, areas, and running infrastructure service is difficult. This is where Azure really kind of provides you a lot of benefit because across, you have data centers across the globe. You've got in Asia, Europe, US. I haven't seen anything in South America yet, but I'm sure there's something that'll pop up pretty soon. Is you have the ability to be able to create that network up there so that your clients have the smallest latency and not necessarily moving all the way across the globe to your infrastructure out there. All right? So that is a key value proposition for Azure, and that's something that you can enable for domain controllers as well. So you can host some of these. If you decide that you have a whole bunch of users coming up in Asia, then you can create a virtual network that is fundamentally in Asia, create domain controllers, create that site, and be able to replicate the traffic. Now, based on DC location, all the users out there will fundamentally bind to your virtual network site and will be able to find those DCs first, and your latency should be a lot smaller.
Just to be clear about that, put it in Asia, Asia's the size. Europe, it won't replicate that instance, it won't replicate Europe. Unless you create another VM.
Actually, so the core logic within the domain controllers in an Active Directory for us, it handles making sure that the right data gets across to everywhere. So you will be, when you create sites, you will still be creating site links between that site to an appropriate site, which is possibly the closest for it to talk to each other. So if you still created a site in Asia, you will still create a site link between your Asia and your closest on-premise network site. And that will set up that site topology for changes to flow across from your inside your network to the necessary that site. Does that make sense? Okay. Okay. Now the key thing is that Azure today does not support two different virtual networks to be able to talk to each other in this pattern. So they still talk through the tunneling scheme through which, and they will be able to kind of do that. That's purely from but once resolution happens and you figure it out, then the traffic is optimized for that.
One question. What does this geo-redundant storage mean in Azure?
It means that, for example, ultimately all of these virtual machines are under as Azure blob storage. And somewhere it's on some spindle that's out there that it has access. Fundamentally, it means that spindle exists in that geo site. If it means Asia, that spindle exists somewhere in Asia. So that, and plus the resolvers, all of those things, where all the way from their forward, there are these front load balancers, there are DNS resolvers, all of them essentially handle that region so that it's the quickest. So when you're doing a DNS query out there in Singapore, you might hit your DNS server out there. And similarly, when you're reading or writing, fundamentally reading from the directory, it's reading from data that is essentially located in Asia. But it might still replicate with America, but it's located in Asia. It's not very different from you having your own network out in Asia, and you've set up the necessary network configuration, whatever pipe that you have, that spans across some WAN link to be able to get connectivity between your office in Singapore versus Europe.
Can customer select where they locate?
Yes, yes. But now, think of this more at the concept at the unit of a virtual machine and not as purely as data. So it is the unit of the virtual machine. So when you create a virtual machine, you can create affinity groups as well, or you can say, you can specify which data center do you want that virtual machine to be on. So, any other questions? All right. I'm also going to, since I have a bit of time, before I get to wrap it up and open it up for questions. The other thing that we will also be releasing as part of our white paper is how you think about federation service as well in some of the newer scenarios. We do have Active Directory Federation service, and we've had a bunch of Office 365 customers use Active Directory Federation to connect up to Office 365 service using your Active Directory. So inside your network, it looks like you're seamlessly connecting. It doesn't matter that that service existed in the cloud. We call it desktop single sign-on. All right, just because you logged into Windows, you get that seamless sign-in experience to a cloud resource, which has no Active Directory Forest Trust relationship. So that's one of the things. However, we've also had customers who brought up the fact that, hey, one of the things is we're now more in the motion of not buying any servers. For us to get that ability to support, I have to deploy additional hardware in my data centers to actually go do that. When you think about that, and you're more in the all in the cloud type of a strategy, then in that case, it works great. You can set up a full environment for your federation capabilities up in the cloud. We would recommend that, like, the way that would look like is that you would fundamentally have two virtual networks. You would have your domain controllers and STSs co-located on virtual machines in one network, which has no view to the extranet, but it has a cross-site connectivity back to your corporate network. All right, domain controllers can interact and replicate traffic. You would set that up in that fashion. Then you would set up another network which kind of resembles, let's say, your extranet, right? So that that network is essentially accessible through a VIP and through an external endpoint where end users can see that. But you would place the proxy, STS proxy machines that are more set up such that you have key isolation. You don't have keys to your kingdom, available on the edge. So these proxies are capable of proxying traffic and, validating certain things before it sends it over to the STS. And then you bridge that by the proxy talking to an STS directly through using the dynamic IP address. So that's a way in which you could set up a full separate environment in Azure IaaS. And for customers who are thinking about using Federation service for Office 365 or for even third-party cloud applications as well, that's something that you could consider. But the nice thing is that let's assume that something went wrong in your own data center, right? Now, Federation service is very much like a web service where it can be load balanced across multiple nodes. If something went wrong in your internal data center, all you would have to do is switch your global DNS to point to that extranet VIP endpoint. And pretty much it looks like anyone from inside or outside is essentially talking to that cloud resource as if they're calling from the extranet. So this reduces your impact of downtime to a mere DNS switch and potentially 5 minutes to deal with TTLs and caching. For you to be able to kind of get you're back online and you're being able to connect to the cloud resource and get the benefit of all the reliability of a cloud application itself, providing that set of resources. So that is a way we'll be talking about that in the white paper as well, in how you set that up and run it up. But now, if you forget thinking about it as a purely isolated environment, you can now think about it in very similar ways that we already talked about. You can think about it as an additional disaster recovery site. It's still out there. No one's using it. But at the same point in time, if some event happens, you have now the full capability of you to be able to continue to provide access to applications without losing a beat, without, or rather, you just need a DNS switch to actually enable that. Or you can think about it from the perspective of thinking about your geolocation as well. Just as we talked about domain controllers and being geolocated, you can create your sites based on whatever your need is for geolocation to be able to perform authentication at the lowest latency possible based on where your end users are. Any questions? Sorry? Sorry? ACS does not necessarily... by the way, ACS is Access Control Services. That was the old term that we were using. It's all part of our overall Windows Azure Active Directory. There's a series of components that actually make up that. ACS is one of that. ACS does not have the ability to authenticate an Active Directory credential directly, and that is the key reason. So you would use ADFS when you want to use your existing Active Directory to authenticate, to provide a token to a cloud application to do that. So if you were building your LOB applications, you might bind it to ACS, but ACS will still federate to Active Directory Federation service if you want to authenticate with your Active Directory credentials. ACS does provide the ability to use certain consumer ID credentials like Facebook or Google or Microsoft account, as it's called now, and we would also be able to use like any application bound to Azure Active Directory will be able to use identities authored within Windows Azure Active Directory, or be able to use identities that can be authenticated by an on-premises system through federation. Yes, go ahead. Okay, so the question was, on a member server, how do I configure the DNS setting? There are two ways that you can do it. One way is that you can set on your virtual network, there's a virtual network configuration file, you can set the DNS servers on it such that any machine that is added to that virtual network will inherit those settings, just like you might set it for your DHCP server when you get it from your DHCP. So when you get a lease for the address, then at that point in time, you will get those DNS server settings. However, with one exception, you will need to know the IP address of your DNS server prior to setting that, all right? And this is why right now within Azure, because of this, we don't know, like if you were using the cloud domain controller as a DNS server, we don't know that IP address up front for you when you create the virtual network. So you have to create it, and then right now you have to go to the machine and manage that at this point in time. You can still connect to the machine, and that can set the DNS on it. This should be fixed by GA, where you can just set it on the virtual network, and your machines will just get it automatically. Does that answer? Sorry. For now. If you're using a domain controller that was in the cloud. So if you're still going using your tunnel, you can set that on the virtual network, and that should be fine. Any additional questions? Sorry. There are some. We're still working on it. We're making sure that we validate this before GA. Our goal shouldn't be, no, but we're still working through it. As probably with any typical answer, we can't give you a direct answer about that. Soon. Don't ask me to define soon. All right, thank you, folks. I will be around. We're having a few more sessions. I'll be doing a couple of sessions. Tomorrow we have sessions. I'm looking from the perspective of Active Directory and our cloud. Tomorrow we have sessions about our Office 365 and Windows Azure Active Directory at some level. Ross out here. Is it Thursday? Sorry, Thursday a.m. And that also conflicts with a session that I'm doing about what's new in Active Directory in 2012 on Thursday morning. And I do have a session right after that that focuses on a lot more details about virtualization and domain controllers and cloning in Windows Server 2012 and how to think about it from the perspective of your forest recovery solutions. And then we also have, during lunch session, we have a chalk talk with a series of folks on Active Directory. Tomorrow we do have sessions on dynamic access control as well, which focuses on how we've added claims-based access control into the core of Windows. So that's something that I'd highly encourage you folks to go. Thank you so much.